Okay, in this video, we are going to using the solver to help find the alternative optimal solution for the transportation problems. So in this transportation problem, we already identified the objective function, the constraints, and then so we also solve the problems. Okay, we also solve the problems. Okay, from the previous example, we already know the objective function is optimized at the 39,500. Basically, it is the minimum amount of cost we can have. And at the same time, we notice that we have several route actually doesn't have anything produced. Okay, anything produced. So then the question here, as we go back to look at my answer, so everything is bonded. Okay, everything is bonded. And then we notice that we have several factory actually have nothing shipped. Okay, so the question here is if we, in order to find alternative solution, maybe the answer would be those zeros. If any of those places have more than one unit shipped, but at the same time we can keep the cost the same, we are able to find alternative solution, right? So therefore the thought process is, given we found the optimal solution, in order to find alternative, so the first thing is we need to add in a constraint so that this minimum cost function still be satisfied. So this cost still equal to 39,500. However, we might able to find maybe x13, 14, 22, 32, 33, 34 can have some kind of production. So we still have this cost function. So therefore, the objective function in order to find the new optimal solution, the objective function will be changed. So what are going to be my new objective function? So the new objective function will be the summing all the choice variable that are zero together. So that will be my objective function. Our goal is try to optimize those zero so that they will not be zero. But then we're going to add in one more constraint, that is make sure our cost still equal to 39,500, because again, this is the minimum cost we can find. We don't expect we can find anything smaller than that. So will be my constraint that the cost has to equal to this one, and then set my objective function equal to adding all my zero choice variables together. That would be my objective function. We try to see, are we able to optimize that so that it's become non-zero. Okay, so let me first, coming back, typing. Okay, for my alternative optimal objective function will be sum all, or my objective is max sum of zero value of the choice variables. We try to optimize that. So because if we can still optimize that, and then that'll be good. Constraint. So my constraints will be still the same because the limitations are still the same, except we're gonna add in one more. Okay, so the constraint will be still the same. So the max here will be maximize x. What are those zeros we have here? Will be 1, 3, 1, 4. Okay, 1, 3 plus x 1, 4 plus x 1, 3, 1, 4, x 2, 2 plus x 3, 2 plus x 3, 3 plus x 3, 4. Okay, so this is my objective function. Make sure if we adding all of them together, if they are not equal to 0, if we can find something that adding all those zero value together, it become non-zero. So we are still able to achieve the same cost. So basically, we're going to add in one more cost function. That is called the cost function. So for this cost has to be my original cost function, right? So this is my cost function. So for this one, has to equal to 39. What exactly? 39,500. So this has to be satisfied. So we're adding one more constraint, cost constraint. Okay, so now we have set up. Let's go down to the Excel. So here we're adding one more tab. I'm just trying to copy what I already have and make a few changes. Try to be more efficient, right? So this is original setup. So instead of cost function here, we need to first of all moving this to my new constraint here. Okay. No. Okay. So I need to copy, and then this is gonna become my new constraint. So this has to equal to 39,500. So this is related to the cost. Okay, and then my objective function here is change. So this has to equal to all the zero adding together. Again, now we'll do optimizing instead of minimizing. Okay, so this all the zeros add together. So now we can use data solver. So my objective function, I will copy here. And then so for this is maximum, and then the choice variable is right here. And now I will add my constraint. Okay, add. So those are the same operators. Okay, and then adding the second set will be here. And then they are all equal sign. Set up my rest constraint. And then, okay. Now negativity constraint selected. And now I will do solve. Answer sensitivity and then click OK. Okay, now let me go to my answer sheet. Yeah, I need to change the name. It's no longer called cost. Okay, now if you look at, yeah, it's different, right? The original value is 1,400. Now we have for 3,400, 500, 1,500. So if you look at my cost, the cost still bonded. Okay, 9,500, 39,500. Again, so here I need to change in the cell name. Initially, since this is not cost, this is the zero. They're the zero choice variable should be the sum of zero choice variable. Okay, so now you can see the choice variable are zeros. Now, no, if you sum all them together, no longer 2,500. So under this is alternative solution. So it still costs the same amount because this is bonded. So the cost still be 39,500. But the difference is the something changed. Look, here used to be 0, now it become 2,500. And then here 1,400 now become 3,500 and 1,500. So this is the way we can find alternative optimizations. So the step is first you need to run to getting your original optimization, and then second step, setting the sum of the choice variable that are zero together as your new objective function, and then making your original objective function as one constraint, making the optimal value as the limit. Okay, so this is the answer for the alternate solution for the transportation problem.